Hello. Yes, we welcome you back to PSSB, um, Physical Sciences Survivability with me, Richard here. Yes, yeah, we are looking at this question. It's a grade 11 question. It says that consider the equation below. This is the equation. We're having sodium chloride reacting with water to give you these products. And they say 4 kilograms of sodium chloride is mixed with 3 kilograms of water. And they say calculate the mass of sodium hydroxide that is formed. Okay, and how do we start with this? Okay, here you have to be reminded that the first approach, the first step must be to determine the limiting reagent. Okay, so what is the limiting reagent here? You have to know that it's either this or that. So what do? We put them down. You have sodium chloride and water. The ratio is 2 to 2, as we can see. Then you have the mass of sodium chloride, which is 4 kilograms. And you have the mass of water, which is 3 kilograms. Our intention is to determine number of moles for each. To determine number of moles, you'll need molar mass. So the molar mass of sodium chloride is 23 plus 35.5, giving you 58.5. And the molar mass of water, it is 2 plus 16, giving you 18. So from here, what do? We proceed to get the number of moles. And in this case, it's going to be N as equaling to M over capital M. That's the formula. So do we know M? Yes. We have to know that our mass is supposed to be in grams. So what we have here is going to be 4,000 grams. The same applies here. It's going to be 3,000 grams. So what we have here for sodium chloride is 4,000 divided by 58.5. This one gives the number of moles. Yeah, we have that. Then when you come to water, what do we have? It's the same formula. N is equal to mass over molar mass. So when you substitute for mass, it is 3,000 divided by molar mass, which is 18. This one will give you so you have the number of moles for water. Next step is now to perform the comparison. So we are having sodium chloride. The ratio is 2, and the number of moles is 68.38. Yeah, for water, remember the ratio is 2 to 2, so we can determine which one is required. So 2 to 2 is the same as 1 to 1, implying that when you use 68 moles of sodium chloride, because the ratio is the same, it will require the same. You don't have to perform any calculation here. So it's going to be 68.38 as the number of moles of water required for this reaction. So next, you come with our water, and what do we say? You say supplied minus required. So what is supplied here? Supplied for water, it is 166.67, and the required is 68.38. What does that mean? That we are going to have a positive difference. Let's have it. Yeah, this is what we have. Now, you need to know that if this difference between supplied and required is positive, it means that whatever entity you are dealing with here is in excess. And if it's negative, then it means that whatever you are dealing with is the limiting reagent. So this is the water we are talking about here, and it's positive. So what does that mean? It means that water is in excess. And if water is in excess, it means that sodium chloride is the limiting reagent. So we can say here that therefore sodium chloride is the limiting reagent. So that is it. So what do we have here? This is excess here, and this is the limiting. Yeah, then after determining the limiting, then we can proceed and determine the mass of sodium hydroxide that is formed. Here, I would urge you to rewrite the equation, which is going to be 2 sodium chloride plus 2 water, giving you chlorine plus hydrogen plus 2 sodium hydroxide. So from the equation, what do we do? We earmark the parts we are going to use. The question wants a mass of sodium hydroxide, so we are going to use this. But we have just established that our limiting reagent is sodium chloride, so we are going to use it. So these are the 2 parts of the equation we are going to use. And you have to remember that we move from known to unknown. Okay? So our known is this. And what do we know about it? We know its mass, which is 4,000. And we are looking for its number of moles. What else do we know? We know its molar mass, which is going to be 23 plus 35.5, giving us 58.5. From here, what do we know? We can proceed and get our N through what equation? The equation is N is equal to M over molar mass. When we substitute for this, what do we have? The mass is known, is 4,000 grams, and the molar mass is 58. You have to remember that we did this step already. So in other words, we know our N as, so we have it here. So this is it. These are the number of moles of sodium chloride which reacted. But you have to remember that when you look at this comparison between the 2, the ratios are 2 to 2, which means 1 to 1. So if you have this one as 68.38 moles, it means that this side is also going to be 68.38 moles. That's what a mole ratio 1 to 1 implies. So from here, you can proceed and determine our sodium hydroxide. Okay, you have just known that its number of moles is 68.38 moles. What else do we know? We know its molar mass because we know its formula. So it's sodium hydroxide. So when you look at its molar mass, it's going to be 23 plus 16 plus 1, where you get 40. So when you have number of moles and you have molar mass, you can now determine the mass. Okay. Yes. How do we get the mass from this equation? The equation is N is equal to mass over molar mass. For the N, we know it is 68.38. And the mass, we are looking for it. But we know it's molar mass, which is 40. What do we do here? We cross multiply. And you get your M as 68.38 times 40. Yeah, that's what we get, which is 2,735.2. And if you want it in kilogram, it can be 2.7352 kilograms. Yeah, then we come to this question, part B. It says that at the end of the reaction above, it was found that 1.8 kilograms of sodium hydroxide was formed. And the question says that calculate the percentage yield. Okay. How do we approach this? Okay, here we must know that a percentage yield is equal to actual yield over theoretical yield. Okay, yes. But what is the actual yield? Actual yield is what is given here. So our actual yield is 1.8 kilograms. And theoretical yield is what we calculated as the maximum mass. Yeah, which we found as this 2.735 kilograms. So what do we do here? What do we do here? We go ahead and substitute. Okay. So in other words, if you substitute for actual yield, it's going to be 1.8. And theoretical is going to be 2.735. Then times 100. What you get is going to be the percentage yield. Yeah, that is it. So our percentage yield is 65.81%.